Alright, so now we're going to start comparing a little bit of linear with exponential. So we're going to find the y-intercept and rate of change of the first function. That's step 1. Step 2, find the y-intercept and rate of change of the second function. Compare the two functions. Which one has a greater rate of change? Which one has a higher y-intercept? Compare the following functions. F of x equals 4x minus 5, or g of x equals 4 raised to the x minus 5. It's right here. You either plug them in your calculator or you create a function table. And notice they used what we used in class. We make our function table, so if you plug in -2, you get -13, -1, you get -9, 0, -5, and 1, -1, 2, 3. Plot our points. Notice that that's linear. We also notice that's in slope-intercept form. So this is f of x. Alright. Now, g of x, same thing. You can plug numbers in, or you can put in your calculator and create your table. And we notice we got -2, -4.9. Notice we also have our asymptote here is -5, not going to cross -5. -1, -4.7, 0, -4. We see our y-intercepts here. Alright. 1, -1, 2, 11. So we look right here, we notice that g of x has a greater y-intercept because -4 is greater than -5. Alright. We also notice that when our x value here is less than 1, so our x value to this way, we notice that f of x, which is our linear equation, and this is g of x, has a greater rate of change here. Notice this is flattening out on g of x. It's pretty flat right here. We notice that our rate of change less than 1 here is going up by 1, 2, 3, 4 over 1. And the rate of change here looks like it's not even. So we notice that f of x less than 1 has a rate of change of 4 over 1. And you know it's going to have a rate of change of 4 over 1 because it's linear. Now our rate of change here is almost 1 over 1, because that's where it's meeting at right there. Because we know we got 1 and -1, so we take it from the y-intercept to there, so it's 1 to 1. But you also notice that the exponential equation, when x is greater than 1, so we'll look to this side when x is greater than 1, notice how my line's going to shoot straight up. So when x is greater than 1, then g of x here has a greater rate of change. Alright. Alright, our next one is a word problem here. Lena has offered a job with 2 salary options. The first is modeled by function f of x equals 500x plus 31,000. Notice on this one, it's linear equations in slope-intercept form, where f of x is her salary in dollars and x is the years. The second option is represented by the function g of x equals 29,000, which is her start, times 1.04 to the x power. Where g of x is her salary in dollars after x years. Lena is hoping this position for at least 5 years. Which salary option would be the one she needs to choose? Support your answer. So right here we notice we start off at 31,000 for our linear, and we get an additional $500 every year. So after 2 years, it's 32,000. 4 years, 33. 5 years, it's going to be 34,000. Alright, or excuse me, 6 years, 34,000. Now after 5 years, it's going to be 33,500. We know this is our line right here because it's linear. And you can see the thousands as they're going up to 35,000. Notice right here in the exponential, you start out with less money. Now our percent increase here is 1.04, so it's increasing 4% every year exponentially. The next year we plug in a 2 for our equation, and we see that it's increasing 31,000 to 31,366. The next year, 33,923. Alright, in the 4th year, notice that we're starting to eclipse our linear equation because it is growing exponentially. So the longer you're there, the potentially you'll increase in your money. And also we see right here that it grows past it by year 4. So in 5 years, we know that g of x is going to be our better option. Now these are going to meet at a point. Obviously we see they meet at a point here. Now this point is not going to be one of these points. Possibly, if I was going to imagine what year they would be close to meeting, would be year 3. Alright. Now y'all try the work time and be ready to come into class and look at this tomorrow.